Now, before we really kind of dive into kind of the quality side of things, I just want to do a quick level set around DevOps and digital transformation and that type of thing. Because we often hear these terms kind of spun around, and they lead into why we care about infrastructure quality. And I like to say we like to start with digital transformation. This is the thing that's going to help anchor the technical efforts that we undertake, right? There are all sorts of fun things that we can go do when we start going down the DevOps route or the WinOps route or whatever, right? But unless we're able to kind of take and apply those technical improvements, those technical changes back to things that help drive our business forward, there's not going to be the support there to do it. One of the things I hear from folks often is like, hey, how do I get my manager or my director or my VP or whatever person in the chain of command there to let us do these cool DevOps-y type things? How do they let me do Chef or Puppet? Where can I go do containers and this kind of thing, right? And when we start at a place of, hey, there's this cool tech thing I want to go do, it usually doesn't go very far. Or if it starts, it usually doesn't last very long. It tends to be one of the first things that gets cut. But when we start from a perspective of looking at what's going to help deliver value for our customers, how does it fit into the chain of delivery, right? How does it help us improve our business process or transform the products and services that we're delivering? That helps cement our ability to do the cool technical stuff, right? DevOps, WinOps, all the cool fun stuff is what falls out of focusing on digital transformation. We can't deliver awesome stuff unless we're doing the right things. When you look at like the results from like the State of DevOps report over the past few years, or look through the Accelerate book, right? What you see is, regardless of what you call it, DevOps, high performance IT, site reliability engineering, WinOps, whatever label you put on the thing, it all boils down to a handful of practices, but those practices don't stick around unless we can tie it to the value that we're delivering for customers. So, when we focus on digital transformation, we get DevOps. And what's DevOps? Well, Jeffrey Snover likes to put it as automate things and don't be a jerk, right? There's other definitions of DevOps out there, but this kind of sums it up, rather nicely. And why do we want to do this DevOps type stuff? Well, going back to that State of DevOps report, as of this year's report, organizations that are not improving are actively falling behind. For a long time, it seemed like the low performer category seemed really stagnant. Now we're starting to see separation out. More folks are landing in that middle tier. More folks are landing in high performance, and to the point where they're tiering out the high performance and setting out an elite performers category. Now, there's actual measurements saying that the elite performers are 1.5 times more likely, high performers X number of times more likely to meet and exceed goals. What are those goals? Things like profitability, market share, customer, numbers of customers, satisfaction, whatever it is, right? Whatever these things fall out for your organization, if you are a high-performing IT organization or an elite-performing IT organization, you're much more likely to be delivering well on these things. As I said, we're starting to see kind of a separation in the market where the low performers, those people who are staying there, are starting to fall behind, and more folks are landing in the middle and high and now elite categories. The problem is as we start out in that low performance, we start to automate things, and we start to deliver more quickly, stuff starts to get painful. Nobody tells you about this when you start out. They're like, come, do the DevOps. It'll be awesome, right? Let me sell you some cloud, and it will all be fine. I'm here to tell you it's a lie. Unless you're doing the right things. And we're going to be talking about one of the right things here in a minute. But as we start to go through the arc here, right, we start to identify those quick wins. We start to automate. We're going faster. That's when the pain creeps in, because as we start going faster, we haven't yet bumped up our quality. We haven't caught the things that cause problems when we land in production, because guess what? What causes problems? Change. What did I just say we're doing faster and more often? Change. So, as we start to see, as we start to go into that kind of middle tier, as we start to go faster, we start ending up with spending a lot more time on manual testing. We didn't have to test as much when we were in the low performance category because we didn't change things as frequently. We still had to test it manually, but now that we're changing more frequently, we're going to be testing more manually. Now, when you see that jump from medium to high, you cut out a whole lot of manual testing. Automated testing is the secret sauce to moving you from that middle tier where it hurts towards that high performance where it starts to feel a little bit better. There's a money cost to this thing too. There's lots of little numbers and little words on there. You can find this stuff in the State of DevOps report. Basically, rework costs money. And while we're in that medium performer, we're doing lots and lots of rework. Low performers have a good amount of rework, and high performers, less. So it becomes, when we have problems that make it all the way to production, whether they're technical, security, whatever, production is the most expensive place to fix problems. However, that's where we usually end up fixing those things. Does that all make sense? All right. Well, let's get testing. So, we're going to talk a little bit about infrastructure testing here. And we're going to start out, because this is Chocolatey Fest, talking about testing Chocolatey packages. Now, I'm a fan of, and we've heard a little bit earlier today about Test-Kitchen. Test-Kitchen is an integration testing framework. It's an open source project, and it's included with things like Chef Workstation or Chef DK. You can also install it if you have Ruby. And as of today, there exists a provisioner for Chocolatey for Test-Kitchen. Now, of course, my Cloud Shells are starting to time out, but I talk too much, and so my Cloud Shell times out on me. Yeah, sign in. Now, one of the nice things about Cloud Shell, anyone hear Cloud Shell before? Handful? All right, so this is, because I work for Microsoft in Azure, this is my little Azure bit. I like the command line. I like the cloud. It's my command line in the cloud. It has all my tools that I want, including Chef Workstation, Test-Kitchen, Terraform, Git, whole bunch of other tooling. Azure PowerShell's there, and a whole bunch of other fun stuff. But for today, we're going to focus on the fact that Test-Kitchen's there. So let's go back to my folder here. Let's see. Oh, not ChefConf. This is Chocolatey Fest. All right. Now, another nice handy thing in Cloud Shell is I have basically the VS Code editor. So I don't have to install this stuff to kind of bring it along with me. It's just all there. So I can go to shell.azure.com and be off to the races. Now, what we're going to look at today is how we wire up Test-Kitchen to provision and test Chocolatey packages. I'm going to use the Azure Driver because, again, I work at Azure and I get a bunch of money for that. No, I work at Azure, and and Azure is a great place to deploy your workloads. So I work at Azure and I have Azure subscriptions. So that is where I'm going to test. You can also use Hyper-V. You can use VMware. You can deploy to those other clouds like AWS and Google. There are drivers for all sorts of things. A driver is basically a way to spin up a virtual machine. I give it a little bit of information, machine size, where I want it to spin up, and the subscription I'm going to tie it to. And then in my file system, I've got a little credentials file that it knows how to go and actually apply credentials to spin up the resources that it needs. Then I can specify a provisioner. The provisioner is what is going to go and make the changes to the system that we spun up. I'm going to specify Chocolatey here. We're going to look at the DSC Provisioner in just a little bit. And I can give it some properties or parameters. I'm going to give it a package name, so I just wanted to install the Git package. It's an easy one to understand. There's some known behaviors. When I install Git, it's going to put Git on into my command, into my path. It's going to add some other tools and stuff, so it'll give me some things to test. Then we get platforms. This is one of the powerful things about Test-Kitchen, is you can specify versions of virtual machine images or catalog images or whatever variation of thing you want to test. And Test-Kitchen will use that to build out a test matrix for you to test against. So we're going to start here with Windows Server 2016. We can add other versions in, so we can test the behavior of our provisioner on multiple platforms. What this helps is it helps us accelerate the adoption of newer platforms. We can test to make sure the things that we expect to work there will work, or if we're providing utilities, like if we're providing public packages and we want to test it on multiple platforms, gives us a great way to go do that. So I'm going to specify Server 2016. I tell it the Microsoft Azure way to find that particular image. Transport is how we connect to machines. So it's either going to be WinRM or SSH. You can provide additional options. We're just going to use the base behavior. Then we get down to Verifier. This is how we're actually going to test that the thing did what we expect it to do. Anyone here using config management in any way, shape, or form? All right. I don't know about y'all, but configuration management tool running in the background on my servers that's going to change the state randomly scares the living crap out of me. Because I like to control my server environments. I'm a bit of a control freak, growing up in operations does that to you. Because again, we go back to when things change, things break, and then I end up on a conference call and trying to justify why the developers broke it and not me. Now, so if configuration management scares me, but I want to do it because it helps me manage my environments, how do I build that trust in the system? Well, I build that trust by using a separate tool to validate that the thing that's telling me it did something did the thing I expect it to do. So in this case, I'm going to validate that did the Chocolatey package actually install, that it says, hey, something's installed, actually do that? And did it do it in a way that I can validate the side effects? That's the thing about infrastructure management. Any software devs in the, anyone who does some software development? So when we do software development, very often we'll write unit tests to make sure that our code's behaving the way we expect it to do. And we put a lot of emphasis on those because they run quickly, and they can help eliminate a whole class of problems. Well, when it comes to infrastructure testing, all of our infrastructure management is all about side effects. It's changes to the system. And so unit tests that tell me the config management looks the right way is of limited value. There's some value there, but it's limited. So we need to actually test that the system, when we apply our config management, that changes the system in the way that we expect. And so that's what Pester, as a verifier here, would do. Inspec is an option, server spec. There's all sorts of different options for how you can verify the state of your system. Since we're talking about PowerShell-y things, we're going to use Pester. And then suites, these are the test scenarios. So we can come up with different test scenarios, and we can match different test cases to different scenarios. We're just going to keep it nice and simple here. So we've got our kitchen YAML file that describes how we're going to spin up a machine, how we're going to provision it, which platforms we're going to spin up against, and the test cases that we're going to do. So with that, we can actually spin up a machine. And I've already went through and got machines spinning in the background so we don't have to wait 5 minutes for a virtual machine to come and join us. So I can do kitchen list, and that's going to show me the instances, which an instance is a combination of a platform and a suite. So for every test suite that I have, and for every server image, it builds out a matrix. And so it's telling me that I have one instance because I have one suite and one platform. I'm using the Azure RM driver. We're going to provision with Chocolatey, test with Pester, send all the information over with WinRM, and the last thing it did was create the machine. Kitchen Converge is my command to actually tell it to go start doing something. Now this tool is great for when I'm working and developing my package and, or my config management, and it's going to run through and it's actually executing all this on remote machines because it's not going to do it in Cloud Shell. But it's also good to add to a CI pipeline. And there is an easy way to run all of your tests and then have it destroy the machines if everything succeeds, or leave them around if it fails. Or in the case of in the CI pipeline, you probably want to destroy them all no matter what, but you can have it fail your CI if your tests don't pass. And we're just kind of running on through here. Now, while it goes through and installs this, when this is done, we're going to move on to the next phase. The next phase is going to be the verify phase, and that's where we're going to look at the test. And we're starting with a really simple test. And we're just going to check to make sure that Git was installed. So it's going to take a look on the command line and make sure that, oh, now one thing to mention, when we go to verify, as we're doing this thing, as we're working kind of interactively with it, we can continually make changes with the tests And every time we run verify, it's going to copy the tests over and validate them again. Let's see where our shell, let's see where we end up here. Oh, all right, still running the installer. Now this is just installing off of the regular Chocolatey, here we go. It's installing off of the Chocolatey public feed. We'll get to installing packages locally in just a minute. All right. So now we've got it installed. At least it says it installed. Following my trust but verify, we're going to actually use Kitchen Verify. That's going to take that little pester test and ship it on over. It's going to make sure pester's installed. And if not, it'll install it. And hey, it did what it expected to do. Now, this is a super simple example, but this is the building block for as we build more complicated packages, right? You build some packages that are supposed to configure IIS a certain way or SQL Server a certain way. Now you can write some tests to validate that it's going to go and do those things, right? And that way, it shortens up your, all right, package done, test, apply, and then go look at things in the UI. Or go run some command line stuff in a one-off fashion, right? This is going back to that. We want to remove some of that manual testing process. This also gives it a nice way for us to be able to hand off that that kitchen YAML file to somebody else so that they can go and test and validate that things are as they expect it to be. All right, up next. Now, we've installed Git, we've validated that it's in the right place. Now we're going to start using a local package. Now I've got this in a different directory. I've got it with a fresh machine, so we're starting. We're not. Just so you know, there's nothing nothing up my sleeve. I'm going to run a command against the node that we have here and make sure that Git is not there. Or actually, yeah, Git command. If I can type properly, and don't talk while I'm trying to type, because then I start typing the words that I'm talking. So I'm going to get command Git. Let's see if that exists on this remote node. Nope. It is not recognized. So we want to get it recognized. And to do that, we're going to install Git again. But this time, I've got it locally in a NuGet package. So if I was building this package on my local workstation, I would do my Choco pack, and I can point Test-Kitchen to where that Choco or that nuke package is, or nupkeg, as some people like to say. It sounds weird, but I guess it works. So with our nupkegs in one place, we can upload those, and because this particular package has a couple dependencies, they all have to be present for local testing. And then we can kitchen converge. Now, instead of going out to the public gallery to download these things, Test-Kitchen will bundle these things up and ship them over to the system under test. So it's going to go install Chocolatey just like it did before. And while that's going, I'm going to open up another shell here, and shell.azure is not working. There we go. Just didn't refresh it hard enough. Chocolatey isn't the only thing that we can do Test-Kitchen with. We can do Test-Kitchen with Chef, we can do it with Puppet, we can do it with Ansible. We can also do it with desired state configuration. Anybody using desired state configuration? Okay. So there is a DSC Provisioner for Test-Kitchen as well, which allows you to, in the Provisioner, specify things like version of the Windows management framework that you're using, if you want to allow reboots, all sorts of fun stuff, as well as installing modules from the gallery. And again, given that we are at Chocolatey Fest, we should have a config that uses some Chocolatey. So I have a DSC configuration here that I want to test. Now, the nice thing about the nice thing about the Provisioner here is it supports things like configuration data. Of the folks who are using desired state configuration, anybody using configuration data? Yeah, it's about what I thought. So a good practice when doing configuration management is to separate your environment data from the structural configuration. By supporting the configuration data construct, we support that kind of concept where we can provide the environment data via the test, so we can control the behavior, and we can strongly test our structural configuration. So for our install Choco, we just have a little DSC configuration that will install Chocolatey and install Git. So basically the same thing we were doing before, except via desired state configuration. And we can kitchen converge. In the interest of time, I've already done this, so we're just going to see it actually verify that the Test-Kitchen actually did what we expect it to do, unless I forgot to pre-converge this one when I was restarting all my shells. So we'll see if I did my in interest of time step. Yep, I did. All right. So DSC in this case behaves exactly like we expect it to. It takes a look and says, is the system in the state that I expect? The test phase comes back and says, yes, we are, so we can skip the set. And in the same way that we can verify our Chocolatey packages, we can verify our DSC configuration. And same way, it's going to copy over my test, make sure it's there. Now, the one last thing I want to show you, and before we open up for any questions, is now that I've went and Chocolatey actually came back through and finished installing, and I can also provide all of the parameters and things that I would want to my Chocolatey package. So we also have a package parameters. So if I wanted to make sure that the Git and Unix tools are on the path, and I can verify that with a test, that I can check path, make sure it's got the particular path, it's going to show that there. I can go ahead and do so. So we can go kitchen converge. And when that's done, we'll verify. While that's running, we do have some time for questions. So if you'd like to ask any questions around Test-Kitchen, testing with Pester, Azure, how I look so good on stage. That's a trick question, by the way.
How would you go about testing massive DSC configurations with kitchen test? I mean, if you're thinking 200-300 resources, configurations being called inside of one script, would you break everything out? And then how would you put that into a continuous delivery pipeline?
Sure. So good question. So the question being, if I've got a huge DSC configuration, how do I test it? Especially in a CI pipeline scenario? Well, personally, I would say that 200 or 300 resources is probably too big to test all in one whack. So I would break those things up into composite resources and have tests around each of those things. And I'm not going to test every variation of the configuration. I'm going to test like maybe the happy path of I'm getting all the right stuff, and then I'm going to test a couple of side scenarios, because my resources themselves should have tests, right? This is one pain point that I have with the existing ecosystem of DSC resources, is that it's not easy to test these things, because the test infrastructure kind of assumes that it's running in CI, so I can't locally test the things easily. So for me, what I would do is break those things up. When I actually implemented some of that, I would break it up by role, and then if those were still too big, I would break out subsections of things of common behaviors, and then I can write tests around each of those things, right? Because with the composite composite resource, you're going to parameterize that, and those are the things that you're going to vary. You're going to vary those parameters into, and then validate that it's behaving the way you expect. Then when I compose all of those things together, I don't have as great of uncertainty, because I know how each of these things behaves, right? So that would be the route I would take. And just to be, I love tests. I think we should have tests over everything. That is not how we start out, right? You can't go back and retrofit tests on everything right away. It's not realistic. So starting at a place of, all right, I have to make a change to this particular thing, putting some tests around the small thing that you're doing, and kind of following the Boy Scout rule of leaving the campsite a little cleaner than when you left it, or when you got there. And so having a few more tests than when you first came into that code base is a good pattern to follow. Other questions?
Do you know off the top of your head if there's a virtual machine manager driver for Test-Kitchen?
Like System Center Virtual Machine Manager?
Yeah.
No, I know there's Hyper-V because I wrote it, but I don't think there's a System Center VMM. Though there, honestly, these the provisioners and drivers and stuff are relatively easy to kind of get started on. So if it's something you're interested in doing, I'd be happy to give you some pointers on the route to go.
Cool.
Other questions? All right, who's going to go and start playing around with Test-Kitchen? All right. I highly recommend Cloud Shell. It's a great way to get started with no install. right? You just have, if you've got an Azure account, you can just go, and if you don't have an Azure account, you should go get one. But there's a bunch of free resources in Azure, so you don't have to go pay money to start with this. But go into Cloud Shell, start playing around with these things. I'm going to publish these examples out into my GitHub, so they give you a place to kind of start from. And start playing with the DSC Provisioner if you're doing desired state configuration. And the DSC Provisioner also has support for testing resources. So if you're building DSC resources, there's structure and things in there for you to get started with that. And I think it would be a great thing for the DSC ecosystem to adopt. You know, I'm a little opinionated, but hey, a little biased, but it would give us a lot of flexibility when trying to contribute to upstream resources if there was a common pattern for testing locally as well as in CI. But hey, that's just my 2 cents. Other questions, comments, concerns? People think this is totally pointless. It's all right. I've been known to be wrong. Happened last week, I think. Yes?
Quick question. I assume you could build a multi-cloud test scenario. Would that, does it run in parallel? Would it take all day to do all this?
Awesome question. Does it support like multi-cloud and running in parallel and things? Yes, I didn't want to overload anybody's brain on the kitchen YAML, but it is super configurable, and you can override things and extend things at just about any point. So I could say for this platform, when I specify a platform, I could say this one's going to get spun up in AWS. This one's going to get spun up in Google Compute. This one's going to get spun up in Azure. This is going to be locally in Hyper-V. And there's a -C flag for concurrent that will kick these things off all at the same time. So, or at least as close to concurrent as the threading library will support, right? So you can also do the same thing with verifiers, with drivers. You can say converge this thing, or I'm sorry, with provisioners. Install with Chocolatey here, install with DSC here. None of this stuff is like, it's way more flexible than you want to show on stage. Yeah, if you got questions, hit me up in one of the various Slack channels or community Slack channels or Twitter or things like that. I'm happy to kind of run through some of that. Other questions? Who thinks a Chocolatey provisioner might be of some use? A couple folks, okay. And anyone else? All right, unless there's any other questions, I will be around the rest of the afternoon and happy to talk all things testing and infrastructure and cloud and DevOps and Chocolatey. So thank you very much. How am I on time? I'm about done? Just perfect. Thank you all. Enjoy the rest of the day.